Hello, this is Bronwyn Ailey, local food systems and small farms educator for the University of Illinois Extension, and I'm bringing you my 8th weekly installment of the video log or vlog that I've decided to call Local Food Happenings at the Dixon Springs Ag Center. In the past weekly updates, we've talked about the progression of various fruit and vegetable crops being grown in the high tunnels here at Dixon Springs, but for this weekly installment, I wanted to really focus on the irrigation and fertilizer system that we have set up in the hydroponic tunnel and how we monitor that using the EC and pH meter. So that's going to be the focus for this week's video from Dixon Springs. The irrigation system set up in the hydroponic tunnel at Dixon Springs that also delivers fertilizer to the various crops being grown in this tunnel is made up of just a few basic components. The first of which is the irrigation controller, which we see in this box. And as we pan down, we see a couple of the solenoids. We actually have the tunnel divided into 6 zones, and so we have a solenoid for each zone, and they are wired directly into the irrigation controller, and so they open and close based on the schedule that we have programmed into the controller. When the solenoids open, then they open up and water is able to flow through that individual zone, and then they close back automatically once that scheduled delivery time is complete. The other components in our system include the irrigation plumbing parts, which would be things like the main line, some micro tubing, point source emitters here. You can see going into the Dutch buckets the little micro tubing that's attached to the green stakes that are our point source emitters. And as we move over here to the other corner, we can see our water source, the hydrant, and we do have a backflow preventer and a pressure reducer on that, and those are plumbed into our fertilizer injectors, and you can see they have tubing going down into fertilizer buckets or barrels. The barrel on the left contains Ultrasol, which is a hydroponic solution, water-soluble solution, and I believe it's a 3-15-28, and the barrel on the right contains calcium nitrate. And so our typical mixing in the barrels is 1 pound of fertilizer to 1 gallon of water. So we typically will mix up a 25-pound bag of Ultrasol in 25 gallons of water. And for the calcium nitrate, right now we're running that at about 12.5 pounds of fertilizer mixed in 25 gallons of water. And as we pan up here, just this week we installed 2 additional fertilizer injectors, the ones in the center there, because we wanted to be able to deliver a higher concentration of fertilizer to the 2 zones where our tomatoes and peppers are being grown. These particular fertilizer injectors are adjustable in their ratio of mixed fertilizer that they can suck up into the irrigation line. So as an example, this front injector, which is, we'll kind of zoom in on the adjustment on the ratio, is turned just 1 click above the 1:100 injection rate. So an easy way for me to think about that is that for every 1 gallon of fertilizer water, so water that has fertilizer dissolved in it, is mixed in with 100 gallons of water coming through the irrigation line. as opposed to this injector in the back. I'm trying to get a good view of it for you. We have this injector turned up another couple of clicks so that it is pulling in more than 1 to 100 ratio, but less than the 1 to 67 ratio. And this injector, as well as the one adjacent to it for the calcium nitrate, are plumbed into the two tomato zones or rows, because the tomatoes have a higher nutrient requirement than the cucumbers or the strawberries. And so by allowing us to change the ratio of fertilizer water taken in through the irrigation system, we can apply a higher nutrient rate to the various crops without changing the schedule of the time that the water is delivered. And so that brings us to the discussion on using the meter to check your pH and your EC to monitor your fertilizer inputs into these crops. And so we'll look here at the EC meter that we have. And again, sorry I'm being shaky. I'm still trying to hold this iPad in my hand and talk and move at the same time. But this particular meter allows us to measure the pH as well as the EC or electroconductivity, and we can get the EC readings in either millisiemens or parts per million. So depending on the fertility chart for hydroponic crops that you may be looking at and utilizing to try to help you determine the fertilizer range that you need to be in, some charts may list the EC in millisiemens, or it could be in parts per million. So this particular meter has both options on it. And this would be the probe here. And give me a second to pause. I'm going to readjust so we can look at some different EC readings on some of the different zones within the tunnel here. And so what I will do is in the container right next to the meter is just plain tap water. So we'll get a reading on the pH that's coming out of the water from our hydrant, as well as the pH and EC reading on our cucumbers. And the cucumbers are going to be fertilized at a different rate using a different injector than this row and the adjacent row. These two rows have the tomatoes and peppers, and we have the slightly different or higher injection rate for the nutrients for these two rows. And so I will collect some water from this emitter and put it in a container, and then we will check the readings on each of these sources so you can see the difference in these the nutrient contents. Okay, so I have our 3 different water sources set up here to measure with our meter. And one of the first things to remember if you're using one of these meters, we want to make sure that the end of this probe always stays wet. And they come with this little rubber cap or seal that you put over the end, and you always want to make sure that you keep water in this, and when you put the cap back on the probe when you're finished with it, that there's enough water in this that keeps the probe moist. And so we've got the probe sitting in the tap water, so we'll look and see, we'll turn the meter on, and we will look at what, right now we're measuring the pH. So our tap water here, pH is running about 7.5, 7.6, somewhere in there approximately. And if we push the button for the electroconductivity in the millisiemens, we see that the tap water runs at about 0.22. So that's just what's naturally occurring in the tap water here, municipal water source here at Dixon Springs. And so now I will move the probe into the bucket that has been collecting water from, irrigation water from one of the cucumber rows. So we'll look back over here on the meter and we'll go back to pH. And we see that the pH is at 6.2. And so there is some buffering agents in the fertilizer that helps to drop the pH, lower the pH of our tap water into a range that's better suited for vegetable production. And this may be a touch high for cucumbers. They usually, based on information from a fact sheet from Oklahoma State on hydroponic production, pH range for cucumbers is about 5 to 5.5. So this is still running a little bit high, but based on how the crop is looking so far, I don't think that that's having a big impact at the moment. And if we switch to the EC, we see that with the fertilizer that we're running through, our EC is at about 2.16. And if we again use the EC range provided in the fact sheet that I was looking at from Oklahoma State, cucumbers range, optimum range is 1.7 to 2 millisiemens. So this is just a touch high, but pretty close in that range. And so we monitor this every day or every other day, and if the EC creeps up any higher on here, we will make an adjustment to the fertilizer injector and hopefully drop that down just a little bit more. And finally, we'll move the probe into the cup that we used to collect water from the zone for the tomatoes and peppers. So this is coming from the injector that was a little bit higher ratio. So the second set of injectors that we plumbed into the system this week. So the pH here you can see is lower than it was in the cucumber row. It's at 5.8. And so this is just about right for the tomatoes, somewhere in that 5.5 to 6 range is pretty good. So pH is looking good. And if we switch to the EC, we see it's at about 3. And typical range for tomatoes is anywhere from 2 to 4. And I think the older the plant and the more fruit load that we have, the higher in the range we would want to see the EC. So we haven't harvested any fruit at this point on these plants, but we are setting, the first cluster is sizing green fruit at the moment. And so we may be a touch hot in here, but nothing too horribly bad to be concerned about. So just wanted to show you this week how to utilize a meter to help you measure pH and EC when you're growing crops in a hydroponic system. I hope everyone has a great holiday weekend, and we will catch back up with you next week.